Hey everybody, welcome back. So today we've got an odd looking integral here that we want to compute. We've got the integral from 1 to 2 of e to the x to the x times the quantity 2 plus the ln of x. In order to get our hands on this quantity, we're going to need some tools. So we're going to need the derivative of y equals x to the x. We'll calculate that. We're going to need the product rule for derivatives and some slightly clever algebra. So I think with that said, we're going to get into it. Let's go ahead and compute the derivative of y equals x to the x. Okay, so the first thing we want to do is take the natural log of both sides. We're going to use logarithmic differentiation, which is quite nice. So if I take the natural log of both sides, this x will come down, so that'll be x times the natural log of x. And then we want to take the derivative in respect to x of both sides. And so that's going to give us the following. Okay, so here we differentiate implicitly. So that's going to give me, looks like 1 over y times y prime, or dy dx. And then on the right side, of course, we need the product rule because we've got the product of two functions, and both factors, of course, have an x. So by the product rule, that's going to be the derivative of the first times the plain old second, we'll say, plus the plain old first times the derivative of the second. We can go ahead and solve algebraically for dy dx. And so that gives me the following. But then recall from before, we know exactly what y is, right? We said that y is equal to x to the x power. So most likely you've seen this before, but we're going to need it. So let me rewrite these, and then maybe I'll plug in y. That's fine. Okay, so dy dx is, it looks like x to the x times 1 plus the natural log of x. Okay, so we're going to use that when we integrate, so hang on to that. Okay, so with that said, let's go ahead and take a look at the integral. Okay, so the first thing that I want to do, and you're going to see in a moment why I want to do this. So the first thing I want to do is split up the 2 into 1 plus 1. And you might have an idea, to be honest, because previously in our derivative, we found this. That's sort of motivating why I'm splitting this up into 1 plus ln of x. And I'm hoping to discover the product rule. Okay, so that seems pretty good so far. And so now let's go ahead and distribute. So let's take this as one quantity. So we distribute, I'll distribute this here, and then I'll distribute this here. So that'll give me e to the x, x to the x. And then plus e to the x, x to the x, times 1 plus the natural log of x dx. But if you think about this, if you recall from before, so maybe it's worth saying on the side, recall, we just saw the following. So recall that if y is equal to x to the x, then the derivative, right, dy dx, we said was x to the x times 1 plus the natural log of x. So if I think about this sort of in the realm of the product rule, you realize we have the following, right? So we have the derivative of the first times the plain old second, right? Plus the plain old first times the derivative of the second. So that's actually like an expanded product rule. So I can write it in the following way. And so now, since the derivative and the integral are inverse operators, these will cancel. That gives me the following. And so, yeah, we just continue through with the fundamental theorem of calculus now. So that's going to be, it looks like e squared times 2 squared minus e to the 1 times, well, 1 to the 1. So that looks like 4e squared minus e. So quite a neat little problem there. I hope you enjoyed that. If you like that, give it a like, subscribe, share with your friends. I'll see you next time, everybody. Take care.